Hello friends, you are once again welcome to Maths Clinic Series. In this video we are continuing the series of trigonometry, and this is video number 13. In the video number 13 we are looking at a continuation of angles of elevation and angles of depression, and here we are going to solve series of questions under angles of elevation and depression. Remember video number 12, we started with angles of elevation and depression. So our first question would be this: a bird on top of a tree 15 meters high was observed at an angle of elevation of 75 from the same horizontal ground as the foot of the tree. Calculate, correct to nearest whole number, the distance of the observer from the foot of the tree. Alright, so you can pause the video if you have an idea, you can solve it and then later resume. Now this is the solution of this question. And here we have a bird on top of a tree, and the tree, according to the question, is 15 meters high, and then an observer is observing with an angle of elevation. And so this our observer, you can see the normal ground of the observer horizontal to the ground, and then the observer raised the eye to observe the bird on top of the tree with an angle of 75, which is the angle of elevation. So for us to solve this very question, of course the question is asking us to find the distance from the foot of the tree to the observer, or from the observer to the foot of the tree. So that is our adjacent side of the angle. The opposite side has been given. So with our trigonometric ratios that we've learned, we can say that if you use tan theta, sin 75 will be equal to 15 over d, which is the d representing the distance between the foot of the tree and then the observer. And when you simplify this by making d the subject, you end up writing d is equals to 4 meters. I think it makes sense. Another example will help. This time around, from the top of a building 15 meters high, the angle of depression of a football line on the horizontal ground is 69. Calculate, correct to 1 decimal place, the distance of the football from the foot of the building. So the distance of the football from the foot of the building is more or less the first question that we did, but the first question was elevation and this one is depression. So let's see the solution. So using the sketch of it, this is what we can see. This is the observer observing the ball, and the observer has got a normal side over here, and the observer is depressing the eye to see the football, and the depressed eye makes an angle of 69 degrees. And don't forget that the building is vertical, and so the vertical line and the horizontal line makes an angle of 90 degrees. And so this whole structure becomes right angled triangle. But then if you look at the right angle triangle, we don't have the angle of depression in here, but we can say that if you label this one to be A, B, C, D, then we can also have this vertical line or horizontal line here making an angle of 90 degrees. So I can even choose to use from C to D to solve this question, or solve A to B, right? Any of them will do. Now this makes an angle of alternate, so we can say 69 here could be equal to the value here 69, so that opposite becomes the CB, adjacent becomes AB, and then using your your trigonometric ratio, you should be able to calculate this and get the answer. And your answer, when you do it nicely, you will get 5.8 meters. So solve this and then get your answer as such. Our next question is: a tree and a flagpole are on the same horizontal ground. A bird on top of the tree observes the top and the bottom of the flagpole at angles of depression 45 and 60 respectively. Wow. Angles. A bird on top of the tree observed the top and the bottom of the flagpole at angles of depression 45 and 60 degrees respectively. If the tree is 10.65 meters high, calculate correct to 3 significant figures the height of the flagpole. You can pause the video once again and then try solving this question. Remember, we are talking about two different angles of depression in the same question. That is possible. That is possible. Okay, I'm sure you are done. Let's see the illustration so that you do the detailed work yourself. So when you are done, you get an answer of 4.5 meters. So I'm sure you have done that. So here we have the tree, we have the bird on top of the tree, we have a flagstaff here, okay, and they're all on the same horizontal ground according to the question, on the same horizontal ground. And they say that the bird is observing the top of the flagpole with angles of depression, which means that the height of the bird is higher than that of the top of the flagpole. That is why the bird could observe with depression. So that should be at the back of your mind. See, let's see. So here we can say they have the same horizontal plane. That is the normal side of the bird is horizontal. Now the bird is going to depress the eye to see the top of the pole and depress the eye further to see the foot of the pole. Now the first depression gives an angle of 45 degrees here, okay, and the second depression will give an angle of 60 degrees here. And don't forget that the 60 degrees is still making reference to the horizontal side, not from here to here to be the 60. Don't make that mistake. It will be from the whole of this to that at 60. Okay, so then how do we solve this question? Note that our target is to find the height of the flagpole. All right, now when we make an extension of this pole, or let me just label this one as x first. Let me label the height of the pole as x, and when I make an extension I can get this. And note that when I make an extension to this, the point here and the point down here should be the same as the height of the tree, because the whole of this will form rectangle, and so opposite sides are equal because of the 90 degrees at the extreme corners of the plane figure. Then let's put some labeling, which of course will be of help because we are going to solve by making references to angle ABC or BAC or line AB or line BC. It's good to always label your diagram. In fact, this type of question, the diagram is one of the most important aspects. It's like the moment the diagram is drawn well, you've done about 60% of the solution. The rest is to apply the knowledge of trigonometry to solve it. Okay, so here we've gotten this, and now note this. If you look at this angle ED or triangle EDB, it forms right angle triangle with angle of 90 degrees here. Let me write angle of 90 degrees here. Can you see that? And so the whole of BED is right angle triangle. And again, the side D, C, and then E also forms another right angle triangle. So we have two right angle triangles at that side. Now I can make the reference to the fact that the whole of this length here is 10.65 meters, right? So what I'm going to do is I just have to find the distance from C to D with the help of this angle 45, okay? And by so doing, okay, well, I also still need to find the distance from D to E. If I know the distance from D to E, then I can find the distance from D to C. So first of all, use the whole of the height here, okay, that is the opposite of the angle 60. Angle 60, the opposite is 10.65, to find the side DE. So if you say maybe tan 60, it should be equal to the opposite 10 over the adjacent this. Then after knowing the adjacent over here, let's say if that gives you a particular figure of, let's say, y, Then you can use y and the 45 to find the distance between C and then D. And when you do that, you get the distance D and C, and then you subtract that distance from the 10 that you have here to give you the remaining height of the flagstaff pole. Okay, so this will help you to solve the question. When you are done successfully, this should be your result. Your distance DE, which you are representing by y, should give you 6.1488. I will leave it in 4 decimal places so that I can use it to solve the others. And when you do that of the DC, that's the distance here, surprisingly that also will give you the same 6.1488. So that when you subtract this value from the 10.65, your final answer will be the one that we saw as 4.50 meters. So go ahead and do this and get your answer. With this, we come to the end of this video. Our next video will take additional questions to help you understand this concept. Thanks so much for watching.